The Dogon stone drum is one of those pieces of space history that makes me scratch my head and wonder why more people aren't talking about it. It was a major event in terms of our understanding of the universe. And then it just sort of vanished from the public consciousness. On June 29, 1969, at approximately 7:38 p.m. Universal Time, an unusual signal was picked up by researchers at the Big Ear Radio Telescope at Ohio State University. This wasn't anything like a typical radio wave search for extraterrestrial signals. The source of this transmission wasn't coming from a direction within the Milky Way. Oh no, this was coming from outside of our galaxy. Sure enough, this was an artificial transmission. There were also some other telescopes around the world that picked up the same transmission. But there was only one telescope looking in the right place at the right time to follow up. That would be the Doshisha Radio Observatory in Japan. It picked up the signal again, along with several others. Then it just stopped. When researchers at the observatory looked up in the sky where the signal had come from, they found something weird. The source of the signal was in the constellation Canis Major, which is the lesser-known Dog constellation that lies adjacent to the one we all know, Canis Minor. For its part, the Dogon stone drum didn't have a name at the time and certainly wasn't on any star charts. In fact, it was too faint to show up on most telescopes, until it was confirmed that the mysterious transmission came from the Dogon stone drum. At first glance, the Dogon stone drum appears to be just another B-type star. However, this star is peculiar because it has unusually strong stellar winds compared to other stars of its type. It's a blue giant with a surface temperature of over 10,000 Kelvin. Its light is mostly blue and ultraviolet, and the radiation from its stellar wind actually ejects material from the star's atmosphere at high speed. If the wind from the Dogon star drum was strong enough, it could potentially blast away the atmospheres of planets close to the star. Now, we can't observe this phenomenon directly. This is just a computer simulation of how a star, like the Dogon star drum, might interact with a planet close to its orbit. As you can see, the wind blasts the planet and strips away its atmosphere. This may not sound important, but if life ever arose on a planet close to such a star, it would need to have a very tough atmosphere, or no atmosphere at all. So scientists believe that any planets near the Dogon star drum would likely be barren. But back to that radio signal. When we talk about radio signals, we typically use the term frequency to refer to the number of waves at a second. You can also describe these waves by their wavelength, which is the distance between successive waves. Because the wavelength and frequency are related by the speed of light. Longer wavelengths have lower frequencies, and shorter wavelengths have higher frequencies. The wavelength of visible light ranges from about 400 nanometers to about 700 nanometers. We can see waves with wavelengths shorter than that, like X-rays and gamma rays, but not waves with wavelengths longer than that, like radio waves. Radio waves occupy a huge swath of wavelengths, far longer than what we can see. And while we've identified many different types of radio emissions coming from various sources in space, researchers at the time had never seen anything like this before. Not only was the signal extragalactic, but its frequency indicated that it was coming from a very far away. To identify the exact distance, researchers used a unit called a megaliparsec, or MPC. 1 megaparsec is equal to 3.26 million light-years. Based on the Doppler shift of the signal, astronomers knew that the galaxy the Dogon star drum resided in was between 25 and 40 megaparsecs away. That's so far away that even with the largest optical wavelength telescope in the world, you couldn't resolve the Dogon star drum as anything more than a tiny dot in the sky. You would need an optical wavelength telescope over 300,000 miles across to be able to resolve it, which is larger than the entire Earth. So how did they detect this extremely distant object? They used something called the 21-centimeter line, which is the frequency at which hydrogen atoms emit radio waves. Hydrogen is the most abundant element in the universe, so it's everywhere. And whenever astronomers find radio signals coming in at the 21-centimeter line, they know that they're dealing with a very distant object. It's a sort of cosmic shortcut to knowing how far away an object is. The 21-centimeter line is so ubiquitous, in fact, that it has its own designation, Ra 0.00. All other radio frequencies are measured relative to the 21-centimeter line. In the case of the Dogon stone drum, researchers were able to measure a shift in the 21-centimeter line. Remember, everything in space is moving, including light. So when researchers observed the 21-centimeter line emitted from the Dogon star drum, they noticed that the star was actually moving toward us at about 11 kilometers per second. Because of this, the signal was blue shifted, meaning it was slightly lower in wavelength than expected. However, there was another peculiarity about the signal. The fast-moving stellar winds of the Dogon star drum weren't just blowing stuff away from the star. They were also blowing stuff toward us. In fact, the emission of the Dogon star drum is so powerful that astronomers think it may be responsible for the radio background noise that fills our universe. So we now knew that the Dogon star drum was emitting unusual radio signals and that its stellar winds were also blasting toward us. But what does that mean? Well, as it turns out, astronomers hadn't even discovered the Dogon star drum yet. When they looked into the sky to pinpoint the source of the radio signal, they found something strange. The source of the radio signal was in the constellation Canis Major, which is the lesser-known dog constellation that lies adjacent to the one we all know, Canis Minor. There are actually two possible explanations for what happened here. Either the team at Doshisha misidentified the source of the signal, or what they saw was a brand new star that had been created as a result of a supernova explosion. Now, you may be thinking that a supernova explosion would be hard to miss. After all, these are the explosions that briefly outshine entire galaxies. But remember, the Dogon star drum is really far away. Even though it lies in the constellation Canis Major, it's actually located in a completely different region of the galaxy, closer to the center. We don't know which scenario is correct, but astronomers think that it doesn't really matter. Regardless of whether the Dogon star drum was already known or not, what was observed was a unique natural phenomenon. This isn't the only time that astronomers have seen a star produce an intense burst of radiation. These are called giant radio outbursts, and they've been seen in several young massive stars. As far as we can tell, these outbursts occur when material from the star's stellar wind collides with an obstacle. The material then bounces back toward the star, producing an outburst of radiation. Astronomers believe that a similar phenomenon is happening with the Dogon star drum, except that whatever it collided with is much more massive than anything that astronomers have seen before. So astronomers were faced with a mystery. What was out there that could cause such a reaction? Some astronomers wondered if the Dogon star drum had a very large jet or a massive cluster of planets, but neither of these possibilities seemed likely. A few astronomers suggested that perhaps the Dogon star drum had collided with a rogue black hole. Black holes can wander around the galaxy, especially if they were kicked out of their planetary systems early on. And while rogue black holes are difficult to detect, they make up a sizable fraction of the dark matter in our galaxy. This idea seemed promising, until astronomers mapped the speeds of stars in the neighborhood of the Dogon star drum and found that they were all moving in orderly fashion. If a rogue black hole were lurking nearby, its gravity would likely disrupt these motions. Whatever the Dogon star drum collided with was big and dense, but it wasn't a black hole. And then in 2004, astronomers made an amazing discovery. They found a cluster of neutron stars orbiting the Dogon star drum. Neutron stars are the collapsed cores of dead stars. They're incredibly dense and pack a lot of mass into a small volume. This could easily account for the radio outburst and explain why the signal came from the constellation Canis Major. If the neutron star cluster were orbiting the Dogon star drum, that would mean that the radio signal originated from somewhere else. So after all these years, we finally knew what caused the Dogon star drum outburst. Or did we? While the neutron star hypothesis is widely accepted today, a couple of astronomers have argued that it's wrong. Their argument is based on the strength of the radio signal, which seems to imply that the neutron star cluster must be relatively close to the Dogon star drum. but studies of the Dogon star drum's lights suggest that the neutron star cluster must be much farther away. I guess we'll just have to wait until we can actually see the Dogon star drum with the naked eye to figure out what's going on. Until then, all we can do is speculate, and that is pretty fun. If you enjoyed this episode, please subscribe and leave a comment below to let me know what you think. I'm the host. This has been the Dogon Stone Drum. Be sure to keep an eye out for the next episode, and until then, stay curious.